Hello everyone, in today's video we're going to talk about end behavior. Now when we talk about end behavior, we're really asking what is a graph doing on the ends? When I say the ends, I mean as it goes further to the left and as it goes further to the right, what's it doing? So let's start with some quick notation here. So you're going to see this notation when you're doing end behavior. If they say x arrow negative infinity, whenever you see the word arrow, that means goes to or goes towards in math. So if you ever see x arrow negative infinity, that means as x goes towards negative infinity. Or a better way to look at it, since x goes left and right, as x goes towards the left. So if you ever see x arrow negative infinity, just in your head think as we follow the graph towards the left. And then down here, same thing, but now it's going to go the opposite direction as we follow the graph towards the right. And that's because as x goes towards positive infinity, we're going to go more and more to the right. You're going to see the same notation for y. As y goes towards negative infinity, that just means as the graph goes downwards. And the bottom one here says as y approaches positive infinity, that means as we follow the graph upwards. So if you can remember that x and y go left and right, and you can remember that y goes up and down, you should be able to remember what this notation means. It's not as scary as it looks once you look careful. Now I'd recommend you pause the video and copy this down, just because it's good information to have. The other notation I want to show you is this, and all you need to do here, again, is copy it down or take a picture or snapshot of it. We'll refer to it as needed. Basically, it explains what graphs do based on their degree and their coefficient, which way the graph goes. So just take a picture of this and we'll maybe come back to it. You might need to refer back to it. All right, so let's do a couple examples here. So let's take a look at this. Let's look at example number 1 here. This question's asking the graph of f of x, y equals f of x, is graphed below. What is the end behavior of f of x? So all they want to know is look at the arrows on the end. What are they doing? So all of our choices have that notation I was talking about. So remember, when we read graphs, we read left to right, and then we read up and down. So as we go to the left, what's this graph do? As we go to the left, this graph is going up, right? So we need to find the choice that says as x decreases, as it gets closer to negative infinity, which all of these choices say, right? X negative infinity, x negative infinity, x negative infinity, x negative infinity. Y is increasing. Y is going towards positive infinity. So, hey, look, we can cross out this answer choice because it says y is going towards negative infinity. So we're going to cross that one out. And we're going to cross off this one because it says y is going towards negative infinity. So far we're down to A or C. And that was because, again, it says as x goes to the left, y goes up. And choice C also says that as x goes to the left, y goes up. So now we need to talk about the right. As this graph goes to the right, what is y doing? Well, it's also going up. So does choice A say that? As x goes to the right, y goes up. Yeah, choice A says that. Choice C says as x goes to the right, y goes down. So we know it's not choice C. So question number 1 is A. So when they give you a graph, all you have to do is just find the choice that matches the proper directions and just look at the arrows and make sure you're doing left and right as x and up and down as y. I'll take a look at example 7 here. Now, this is the same exact type of problem. The only difference is they didn't give you the graph. So don't overthink it. Just pick up your calculator, type in the whole equation in the y equals screen, hit y equals, and type 26x squared minus 2x to the 4th minus 8x to the third plus 56x minus 1/12. And you do it right. You might see a graph just by hitting graph. It's really hard to see here with the glare. I'm going to hit zoom 6. Whenever I graph in this class, I always hit zoom 6 just so I can get that's called zoom standard. That means I can see a standard view that everyone that pushes that will see. And when I see that my calculator doesn't show me everything. It shows me a lot of stuff, but doesn't show me anything. So another option to try after that is zoom 0. And zoom 0 will hopefully show us, that's called zoom fit. Zoom fit will show us what the calculator thinks is the most important feature. And they did it, and it did a good job. I don't know, I'm going to be able to get it with this camera. It did a good job of showing what's happening in this graph. This graph is going down on both the left and the right. So this graph, I'll sketch it here. This graph looks like this. There's some other stuff happening in here, but basically at the ends on both sides, it goes down. So we need to pick the choice that says as we go left, we go down, and as we go right, we go down. So let's see. Choice A says as we go left, we go up. That's not it. Choice B says as we go left, we go up. Hold on, that's not it. Choice C says as we go left, we go down. That one's good. And as we go right, we go up. That one's not it. So it must be choice D. As we go left, we go down. As we go right, we go down. So it's choice D. So remember, the whole time you're doing this, you should be using that information that we took a picture of earlier. That's it. These are pretty straightforward as long as you can remember that vocabulary, and as long as you can translate from arrows and infinities and x's and f of x's into just plain language, which tells you left, right, up, down, basically. So that's end behavior. Thanks for watching. Have a good day.